Alright guys, so in this session we are going to talk about interview question related to process management in the Linux kernel. So we'll try to cover almost all of the questions which can be possible from process management in the Linux kernel so that you will be have a good understanding of the questions related to process management. So the first question is what is process? So process is basically the program which is in the midst of execution. So what does it means? It means the piece of code which is currently executing on the processor is called process. Okay. And then what is thread? Threads are the objects of activity within the process. So what does it means? It means thread is a part of process. But if you will talk about the differentiation between process and thread from Linux point of view, the only difference between process and thread is like thread shares the resources between them, but process don't share the resources. Okay. So now third question is what is kernel like kernel schedule individual process or thread? So in Linux basically kernel schedule individual thread. Okay. So we can say the basic scheduling entity or the basic scheduling uh, the part of code is thread for the Linux kernel. So do Linux differentiate between thread and process? No. Logically, there is no difference between implementation of thread and process in the Linux kernel. The only difference which we have in the Linux kernel that is the resource we are going to share between the threads, but in like between the threads, but in between a process we don't share the resources. Okay, so now does program and process are same? No, not at all. A program can have multiple process in it. Okay, so a program can you can say a program multi-threaded C program. Okay, so in that C program you have multiple process will be executing, but a program can have a single program can have multiple processes at the same time. So now the next question is how process is created. So process in the Linux kernel gets created by using the system called fork or the vfork. So do fork call return in both child and parent process? Yes, fork call will return two times, one in the child process, another in the parent process. And the eighth question is which system call will load the new address space and load new program into it. So what will happen in the fork and the v fork call? Basically, we will be copying all the resources from the parent to the child process or the thread. Okay, but the program will start or the process will start executing once you will call a system call exec. Okay, exec. This is the system call I will write for your reference. Exec. So when this system call will execute, this system call will basically load the new address space and then load the new program into the address space. And then how the list of process is maintained in the Linux kernel. So basically we have task structure which will contain the information related to a process. Okay, so Linux kernel basically maintain a doubly linked list of all these task struct. So what does it mean? It means in the Linux kernel you can have thousands of processes available in the system. So each process will be given one process descriptor, which is nothing but a task structure. So this structure is basically containing all the information related to your process. Okay, and Linux kernel maintain a list of all these task struct. From this diagram you can see. So this task struct is basically process descriptor, and this all task struct are part of a task list. Okay. So now let's move to the next question. What is process descriptor? The same which I have discussed now. Like task struct is a structure which is used to contain the information or keep the information related to a process that is called process descriptor. And then what is the size of task struct on 32-bit system? So basically this size of task struct can vary depending upon the machine. Actually, if you have 32-bit machine, if you have 64-bit machine, it can vary, but usually on the 32-bit system the size of this task struct is 1.7 kilobyte. Okay, and then where information of process gets stored in the Linux. So as we mentioned, information of process in the Linux gets stored in the structure. And then the other question is where task struct gets stored in the memory. This is a good question. So basically, uh, for each process, we will have kernel stack in the kernel. So that is called process kernel stack. And this structure will be available on the bottom side of process kernel stack. So if you will see here, so here basically our structure will be present into the process kernel stack. Okay. So now what is PID and how it gets used in the Linux? So basically at a time we might have multiple processes running in the system, or we might have thousands of the process present into the system. So to identify the process we have to follow a nomenclature which can help us to uniquely identify each process. So do that we use process ID, which is called PID. So this PID is basically used to identify each process. So basically each process will have a unique PID given to it. And then what is thread info struct? So basically now we have seen like task structure contain information of a process, and this task struct basically has a size of 1.7 kilobyte. Okay, and the size of this structure, basically the size of this process kernel stack, is around 4 KB in a 32-bit system. So don't you think storing 1.7 kilobytes of task structure in a 4 KB structure is a huge occupancy of memory, right? So if you will, out of 4 KB of this process kernel stack, if you will take 1.7 KB for storing the task structure, so the rest of the memory will be used for other things for process. So 1.7 KB memory in a 4 KB of process kernel stack is a huge memory. So to avoid that, Linux kernel came up with the idea of thread infrastructure. So thread infrastructure is basically a structure which will have a pointer which will point to the task structure. So now what will happen, instead of storing the task structure at the end of this process kernel stack, we will store the pointer to the thread info structure, and this thread info structure will have one more pointer as an element of this structure which will actually point to the task structure. So now instead of storing this whole task structure, you are just taking one thread info pointer in the process kernel stack, which will save lot of memory for you. Okay. So now the next question is how to basically control the maximum number of process in the Linux. So here basically we have the procfs entry. This entry we can use if you are super user of your system. So you can basically give the maximum number of process which you want to allow in a system by following this procfs entry. Okay. And then you have what is current macro. So current macro is the macro which is defined in Linux kernel, which will basically point to the current running process into the system. So at any point of time, if you want to get the reference to the current running system in the process, you can just point to the current macro. How the current macro is implemented in Linux kernel. So how it will be implemented, it's like for each process running, we will be having one task structure as you mentioned. So this every time when new process gets scheduled, so that structure for that process will get pointed out by this current macro. So when you will ask current macro to point to the next task struct, so obviously this current macro will point the pointer of that task structure. Okay. So what are different process state? So a process in a Linux kernel can be in different states. So this is a diagram which shows different state of a process. So this is like when you fork, so new process get created, it comes into the task running state. What does it means? It means like ready but not running. Okay, and then when scheduler basically schedule this process, it goes into the task running state actually, where it start running, and then from running state it can go to the exit state, like it can call exit, do exit, and from running it can also go for interruptible or task uninterruptible state. Okay, and from task uninterruptible or task uninterruptible state it can go back to the task running state. Okay, so now how to check individual process state. So as we mentioned earlier, we have current macro which points to the current running process. Okay, so in that current macro you have task struct address. So and in the task structure we have an element which state element basically which contain the current state of a process. Okay, so from there you can, or in the simple way, if you want to get the state of any individual task, so basically you have to grab the task structure, and from that task structure you can refer to the state element into that structure. Okay, now difference between interruptible and uninterruptible process. Okay, so interruptible means process is in a waiting state. Okay, so it is waiting for some interrupt or some event to happen or from some signal to receive. So it means when that event will happen, it will interrupt to your process and then your process will wake up. Uninterruptible process means like you are not waiting for any event to happen, you are just sleeping for some time. So the example is like you are sleeping for some 30 millisecond, 40 millisecond. So after 30 millisecond or 40 millisecond, you will wake up yourself. You don't need to wait for an event to occur actually. Although it will wait for scheduler event, but you are not waiting for any input output another event to get wake up. So example of both interruptible and uninterruptible state. Interruptible means you are waiting for some event to happen. Let's say you are waiting, let's say you are waiting for some log to be released. So that is interruptible state. And then in uninterruptible, as I mentioned earlier, like if you are going for sleep for some 30 milliseconds, 40 milliseconds, so that is example of uninterruptible process. Okay, so how to manipulate the current process state? Okay, so to manipulate current process state, Linux kernel provide us the functions or the APIs basically set task state. So set task state API basically takes two argument. One argument is the pointer to the task structure and the other thing is state. So state basically the state which you want to set, that state you have to pass as an argument to the set task state function. If I write the function name here, so this is the set task state API provided by Linux kernel. So now what is process context? So process context is a context in which kernel execute on behalf of a process. This is the general terms. So what does it mean? It means some process is executing in the user space and somehow it needs to get some request done from the kernel. So for that it basically initiate a system call or some other way by which it can transfer the context to the Linux kernel. So when you basically call a system call, so system call will lens down to the Linux kernel. So Linux kernel will execute on behalf of the process which actually called the system call. So that is called process context. Okay. So does current macro valid in interrupt context? So the first question is what is interrupt context? So interrupt context is the context when we are basically handling some interrupt or when we are in the ISR. So that context is when we are executing on behalf of interrupt, we can also say in that terms. So that is called interrupt context. So no, current macro is not valid in the interrupt context. So we cannot use current macro in the interrupt context because current macro is only applicable to the process context. And now what is init process? Init process is the first process which is get created after your kernel is up. After your kernel boots up, the first process which is get created, that is the init process. How init process is used for initiating further processes? So what will happen when your kernel comes up, it creates the init process. Now it is the responsibility of init process to create different processes for your system, let's say user space, it has to create a lot of user space processes. So how it creates is like, and how it will come to know which all process it has to create. So basically there are different etc tab entries or in init tab entry in the Linux system. uh, There basically you specify, like after Linux kernel comes up, which all process you need to create or which all daemon you need to create. So init process basically look into that directory and find out the entry mentioned by developer, like which all process it has to create. So that all process it is going to create at the time of boot up. How process tree is maintained using structure. So the thing here is, in Linux kernel we have lots of process running. Okay, so we might have parent process, child process. So this kinds of relationship is maintained in the processes. So to have a logical implementation of this parent-child relationship, basically we maintain a process tree. So this process tree is like a binary tree, as we have seen in the data structure. So this tree basically contain the structure, and in the structure we will be having parent and child pointers, which will be pointing to the parent and child process respectively. Okay, and then what is copy and write? Yeah, so what is copy and write? So when you basically create a new process by using the fork or vfork, so what happen is, previously like in the old time, what used to happen is, like the time you created a new process, we we basically uh, used to allocate a new memory or the new memory space for the child process. Okay, but there are scenario when you are not at all changing anything or you are not at all updating anything into the child process, but still you are allocating a new memory for the child process. So don't you think it is a wastage of memory? Because we could use the same memory which is parent process is having, because in anyhow we are not going to update anything into the child process. So to fix this issue, a Linux kernel came up with the copy on write mechanism. So what does it mean? Copy on write is mechanism. The thing is, till the time child process don't make any update to the process, we are going to use the same address space of our parent process. Okay, and then what is the benefit of copy on write? As I mentioned, copy on write will save the address space, because you are not going to write, if you are not going to write anything into the memory, so at that time basically it is going to save the space for you. Okay, what is clone system call? So clone system call is basically used to create a process, and in the clone system call basically you can specify, and clone system call, you will not call the clone system call directly. Clone system call will be called by fork. Okay, so what fork will do? Fork basically create the process for you, and the fork will call clone system call. So in the clone basically you can pass the argument, in that argument you can specify what all resources process are going to share among themselves. And now what are the tasks done by fork? So as I mentioned earlier, fork is used to basically create process. Okay, and to create a process, as you know, like we need to create the structure, and then we need to like fill lot of informations. We have to allocate a PID and all this stuff we have to do. So that all stuff will be done by fork call. What is vfork? Vfork is again the system call for creating a new process. But the only difference between fork and vfork is like, uh, when you create a process by using the vfork. Okay, so at that time basically the only difference is like copying of page tables. Okay, so the page table basically is the only difference between the fork and vfork. Okay, so in the vfork basically the page table entries of the parent process are not copied. Instead, the child executes as the sole thread in the parent address space, and the parent is blocked until the child either calls exec, means execute. Okay, and then how the threads are implemented in the Linux kernel. So as I mentioned earlier, there is no difference between process and thread from the implementation wise in the Linux kernel. The only thing is, when you are going to create a process by using fork, so in the fork is going to call the clone. So in the clone basically you can specify the argument, and in that argument you are now telling to the Linux kernel, okay, so this process is going to share uh, these resources like virtual memory, file system, files, signals. Okay, so by this, kernel will come to know, okay, so you are going to create a thread which is going to share these this much resources with the parent process. Okay, and how threads are created? As I mentioned earlier, we can create a thread by using clone. And now, what is kernel thread? Okay, so kernel threads are the threads basically which run solely in the kernel space. It doesn't has to do anything with the process address space, or we can say the user space. Okay, so what does it mean? It means like it will be running only in the kernel space, and there will be no reference of this thread into the in the user space. What does it mean? It means like our kernel thread will not be having any process address space or struct associated with it. So you will come to know about process address space or struct in the next session of memory management basically. So now difference between kernel thread and user space thread. The difference is like user space thread basically runs in the user space uh, context. Okay, or it will have their own process address space. But as I mentioned, kernel thread will not have any process address space associated with it because it is going to run only in the kernel thread. So example of kernel thread is like you can have flush which runs in the background for flushing the memory which is not going to be used. So there are a lot of other kernel thread which kernel use for running in the background. And then for the work queue implementation also we use kernel thread. So which command is used to list out the kernel thread? So basically you can give this command ps-ef. It will list out all the kernel threads running into the system. And then what is kthread create and kthread run? So kthread create is basically for creating the kernel thread. Kthread run is basically running the kernel thread or basically executing the kernel thread. What are the tasks need to be performed at the time of process exit? That's a good question. So the thing is, whatever the thing you have done at the time of fork, the reverse of that has to be done at the time of exit. So what does it mean? It means like you have to deallocate all the resources allocated for that particular process. You have to delete the process descriptor allocated for it. You have to delete the PID which is allocated for it. So all those stuff you have to do at the time of process exit. When the process descriptor get removed, so the process descriptor will get removed when all the object reference to the process which you are going to kill is killed, and all the resources which was allocated to process is removed. So then you are good to go for removing the process descriptor from the system. So what is zombie process? So zombie process is a process which is basically not in the running state, so it is killed basically, and all the resources or the object which was referring to it now, that linking is removed, but process descriptor of that process is still exist. So that is called zombie process because there is no parents of this particular process. That is process is called zombie process. And how parentless task is handled in Linux? So there might be scenario when a process which have multiple child or a single child that can exit itself. Okay, so at that time, so their child will become parentless task. Okay, so Linux kernel has the responsibility of providing them the new parents. So how it do is like it can assign any of the thread from the same group as a parent to that particular process. Or the other thing is like if any thread is not present into the same thread group, it can assign init process as the parent of that uh, particular childs. Okay, so that was all about process management Linux kernel interview questions. Going ahead, we are going to discuss a lot about almost each topic which generally people ask, uh, like process management, memory management, scheduling, interrupt handling, bottom half, top half. All these things we are going to cover in the in this uh, training program, so that you will have a good understanding of all the question related to Linux kernel that can be asked in the interview which you are going to appear. Okay, thank you. Thanks for